Structural supports in civil engineering. Today, we will explore the fundamental types of supports and connections used in structural analysis. Structural supports are essential connection points between a structure and its foundation. They control movement in different directions and transfer loads safely to the ground. Let's examine the three main types of supports. The pin support, also called a hinged support, is one of the most common support types. It prevents translation in both horizontal and vertical directions, but allows rotation. The pin support provides two reaction forces, Rx in the horizontal direction and Ry in the vertical direction. This support is ideal when rotational freedom is needed at the connection point. The roller support is unique because it allows movement in one direction. It permits both rotation and horizontal translation, but prevents vertical movement. The roller support provides only one reaction force, Ry in the vertical direction. This support is commonly used in bridges to accommodate thermal expansion and contraction of the structure. The fixed support is the most restrictive type of support. It prevents all translation and rotation at the connection point. The fixed support provides three reactions, Rx in the horizontal direction, Ry in the vertical direction, and a moment M that prevents rotation. This support is commonly used in cantilever beams and rigid frame structures where maximum stability is required. Let's compare the three support types. The pin support restrains translation but allows rotation, providing two reactions with 1 degree of freedom. The roller support restrains only vertical movement, providing one reaction with 2 degrees of freedom. The fixed support restrains all movement and rotation, providing 3 reactions with 0 degrees of freedom. Degrees of freedom refers to the number of possible independent movements at the support. To conclude, selecting the appropriate support type is crucial in structural engineering. Engineers must consider the structural requirements, anticipated loads, and thermal effects. The goal is to balance stability with necessary flexibility. Understanding these supports allows engineers to calculate reactions accurately and design safe, efficient structures. Thank you for watching this presentation on structural supports in civil engineering.